Andy and Katie, I totally forgot to use this link. So I use another link actually to do the class, and suddenly I remember you guys will be online. I mean, Andy didn't tell me, but I remember Katie will be online. So I'm sorry for you missing the first half of the class. But good news, I'm going to go over these two questions. Whatever you miss, you're going to cover with these two questions. Great. Oh, attendance. It is for 2. Kimberly, absent. Katie online. Judith here. Matt here. Jihad here. Jihad. She here. Jocelyn here. Lucas here. Logan here. Ellen here. Musika here. Nicholas. Matt here. Tanzim here. Shian here. Raka here. Elana here. Apollo here. And G online. They are not same question what do you want to write class, okay? They're similar. The informations are slightly different, and what you're looking for is also different things, not the same thing. Years only for us. 1 year only for us. Not here, right?
Yeah.
So we hope.
Yeah.
I thought you'd do it. I'm just like it's just time. You can study it. This oh, and it's the Lord said no. Everyone is doing. Yeah, no. What are you doing? 1 year and I should be passing. Possible to understand. give the limit function. Demand function. Sorry. Demand minus stays are 1. Second, what did you do? Why did you do? First function is different, right? Good. Right? So how do you solve quadratic equation? Once you bring C on the other side, you bring C on the other side, you cannot solve. Quadratic equation was such a each one side. And do you remember the formula? The formula to solve it. Why did it so 600? 4200. 4200x, so you're okay. 4200x minus 600x. 200x. Santi, how about your 600? Yeah. But what x you had before we take a delivery? 200x minus 600x. Oh, so you here, you go down, and force y out, and force minus 8 minus 3. So this was right. Minus 8 plus 3. Why do you do them? Over 2. The minus 8 x squared. And you get this plus. And it's not the count. No, I don't know. Well, you know what the basis of the sanction is to do that. Yeah, minus 600 to 400. And 6 means that or you can multiply everything by 1, 2, 3. You will also multiply the number. But in the end, just double it. Yeah. So figure out what this will do. Fast that independent. How big is the minus cost? The public, so I need the cost and how to get it more. People really needs how much on this person. So one times how is less of this S times the amount. So for example, what's up? Like the efficient cost. Minus cost, like the other cost. You can choose the lower range, right? Yeah, I can. So I don't want to square root. For passing square root, then obviously it will be bigger than 8, right? It is 70, right? Yeah. Square root of 70 will be equals to 8 point something. Because square root of 9 is 81, and square root of 8, the square root of 9 is 81, square root of 8 is 64. So 70 is between 64, sorry, 8 square. So it's 64. So it's between 64 and 91, so it's 8 point something. 64 and 81, you change these two numbers, so it's 8 point something. If it's bigger than 8.4, that means you're going to just add them, you're not going to use the subtraction sign. Like here we have plus and minus. So if it's bigger than 8.4, there is no minus in this. But if it's smaller than 8.4, then you have two choices to leave that. So find out how much is this in the calculator. But you don't know what is square root of 70. So it's 1.6. So you take a calculator to find out what is square root of that. Yeah, they 8.4. Exactly 8.4. Well, it's 0.40. Wow. Oh, what happened to denominator? What is the A? The A is that 1, right? No. Of course not. A is only going to be square. From 2 because it's square. So why am I one? No, this is A, this is B, and you need to bring it next to ER so you can see. You have to have the format AX squared plus DX plus C. How we are to see what is in the I think it's the question I've seen in the series. Are you ready? Let's do them together, whether you're on activity or not. Because I'm trying to start entitling you. Okay. Me. Yeah, I think one paper is fine. So we are maximizing profit. It's the previous question. We are finding the price that maximize the profit. But here we are finding the maximum profit. Okay. Find the, oh no, not the maximum profit. We are finding the production level. Find the production level that maximize the profit. Production level means what? Number of items. What is? Which variable we have for that? X. In other words, when you solve for X, you're done. You don't have to find the price or you don't have to find the profit. All you need to do is when you set the derivative equals 0, find what is X and you are done. So we have the same problem as before. We are given only the demand function and the cost function. But our profit is revenue minus cost. So we start by solving revenue function. What is revenue? What times what? X times demand. In other words, we have X times 4200 minus 8X. That gives us 4200X minus 8X squared. So first we find revenue because that tells us what is our profit. Profit is revenue minus cost. So revenue is 4200X minus 8X squared. And you're subtracting our cost function. They gave us our cost function is a big one. 600X minus 3.8. Write it down. Minus 3.8X squared plus 0.004 X cubed. I put the parentheses because we're subtracting this quantity. That means all the sign we have here will change. So we have 4200X minus 8X squared minus 13,000 minus 600X plus 3.8X squared minus 0.004 X cubed. We have like terms 4200X minus 600X. And also we have like terms negative 8X squared, positive 3.8X squared. These are the two like terms, so when you combine them, we have negative 0.004 X cubed. How many X squared we have? Huh? When you combine the two X squared, what do you get? 4 point what? 4.2 x squared. And how many x we have? 3600x minus 13,000. So this is our profit function, a big function. Now, since we have the profit function, we can maximize the profit. To maximize profit, all you have to do is take the derivative, set it equals 0. So maximize profit means derivative of the profit equals 0. So we have derivative of the profit in one side, and we have the derivative of the entire last line on the other side. So we have negative 0.012 x cubed, right? Minus 8.4 x. So not x cubed, x squared, my bad. Derivative of this is 3 comes down, 3 minus 1. So 4 times 3 is 12. We have 0.012 x squared. 2 comes down, we get 8.4x plus 3600 plus 3600. And 13,000 has a derivative 0. We set it equals to 0 to maximize. And then you have two choices. Either you divide everything by negative 0.012 to make it smaller, or you can use quadratic formula to solve for x. Or if you don't want to use calculus, you can find the vertex of this upside down parabola. But let me divide both sides by negative 0.012, negative 0.012, negative 0.012, negative 0.012. If we do that, I believe everything will become whole number. We have x squared minus turn into plus, and let's see what do we have here. 8.4 divided by 0.012. We have a big, nice 700x. And since it's subtracting, this becomes negative 3600 divided by 0.012, 300,000. And then actually we can factor this. Think about two numbers, multiply to 300,000, combine to 700. Can you think about such numbers? Can you think of two numbers that becomes 300,000? Or let's think about, if you ignore the two zeros, you're left with 30,000 and 7. Two numbers combine to 30,000 and then become 7 when you combine them. 1,000 and 300. 1, 2, 3, 4, 5. Yeah. Positive 1,000, negative 300. See? You can figure that out. If you can factor, your life is easier. You write down those two factors and then you solve them individually. X is negative 1,000, X is 300. Do we accept both solutions? Which one you cannot accept? Why not? Items cannot be negative. Items can't be negative. So we must disregard the solution. That means to maximize your profit, you need to sell 300 items. So 300 items maximize your profit. And if you don't know how to factor, you can use quadratic formula. I'm just too lazy to use quadratic formula. But if you do use quadratic formula, make sure you have everything to one side. Don't bring everything to the other side. Have everything to one side and then place everything into a quadratic formula. Any question? Okay, the next one. It says, previously we had the volume given, but now the volume is not given. 1200, I have a question, let's see. For the second formula, do x squared minus 4xh equals 1200. Yep, good. You figured that out. In the exam, show me what you did. Either if it's factorable, you can factor. If it's not factorable, at least show me your what is called quadratic equation, quadratic formula. So show me your solving step, then you will find. So see how smart Andy is. He figured out that this 1200 actually is not the cube, it's the surface area. It's the amount of materials you used to make your box. That means that 1200 centimeters squared gives us the surface area. So our surface area is 1200 centimeter cube. It's the amount of material we have for each side, the area. And as we know from before, when you have a square base and 4 sides, the base has same thing. So the area of the base is x squared, and you add the same 4 sides. Now the 4 sides, each side has height h and base x. So area for one side is xh, and you have the same side 4 times, so it's 4xh. So this is 1200. But what you're maximizing? The volume. That means we need the volume formula. So what is volume? Let me do it here. What is volume of a box? X times h, so we have x squared h. We have the same problem what we had before. 2 variables. We cannot use 2 variables. So what do? We go here and we solve for h so that we can replace this h in terms of x. So we go to algebra. Minus x squared minus x squared. We have 4xh is 1200 minus x squared. Since we want to have this h alone, so we divide both sides by 4x. So we have our h is, let's separate them because we have to take the derivative anyway. 1200 over 4x minus x squared over 4x. 4 goes to 1200. 300 times. X goes to x squared, x times. So we have 300 over x minus x over 4. To keep it here and then simplify the next step. Actually, let me keep it here and then simplify the next step. So h is 1200 minus x squared over 4x. So volume is x squared times 1200 minus x squared over 4x. So you can cancel this x with this x squared, we get x. So we have x times 1200 minus x squared over 4, which gives us 1200x minus x cubed over 4. So this becomes 300x and then 1/4 of x cubed. Did I make a mistake anywhere? So we found our volume. Are we done? No. We have to maximize this. So to maximize the volume means take the derivative of the volume, set it equals to 0, solve for the x. So derivative of the volume b prime or dv dx, whatever you want to use. Derivative 300x, 300. And 1/4 of x cubed, 3x squared. That gives us 300 minus 3/4 of x squared. We set it equals 0 and we solve for x. So let's add this amount to make it positive. So we have 3/4 of x squared on one side, 300 on the other side. How do you solve for x? Multiply by 4/3. So the coefficients get vanished. We have x squared. On this side, 3 goes to 300 100 times. So we get 400. Lastly, what do we do? Square root. What is square root of 400? 20. And we ignore the negative because what is x? Number of items. Sorry, x is the thingy, the length. I'm still living in the money problem. It says find the largest possible volume. So what do we do from here? Plug in where? To the volume equation. So this is the volume. Or this is the volume. You can plug it into any one of them. If you plug in the first one, that means you need to find h. If you plug in the second one, you don't need to find h. So if you do use the second one, it's 300x minus 1/4 of x cubed. So 300 times 20, 1/4 of 20 cubed. So we have 6,000. 2 times 2 times 2 is 8. And we have how many zeros? 3 or 4 or 6? 3 zeros? 20 times 20 times 20. 3 zeros. So 4 goes to 8 twice. That means we have 6,000 minus 2,000, which is 4,000. And what is our unit? Centimeter. Centimeter cube. You see, depending on what they're asking, we stop at certain point. In the previous one, they asked for price. What price maximize? Why am I saying price? Sorry. In the previous one, we did the dimension. What dimension has the maximized surface area? And here they want us to find the maximum volume. So once you have your one side, either you can find both sides and find the volume, or you use the one side to get the volume. It's up to you. Any question? Any question from any comments, complaint, anything? So I'll give one of these questions in the exam for you guys. And Ellen, what do you prefer? What type of question you want for optimization? Area of what? Area of function? Do you have any shape in your mind? Circle. You're maximizing circle. And for you guys, is one of these is fine, or do you have any preference? Definitely not the first one. From these two, any preference? So one of these. Which one? I'm not going to tell you. With this, we are done with optimization. Please do the homework. Homework has many other types of scenario, but that's all you have to do. Observe what information is given and what you are optimizing. Now we are coming to antiderivative. Antiderivative is a reverse of the function. So if derivative means you're going forward, antiderivative means you're going backward. So first we have antiderivative, then we have the function, then we have the derivative. That's how we work. Antiderivative, function, derivative. So if they ask you to find the antiderivative, it means you're going backward. If they tell you to find the derivative, it means you're going forward. So they are reverse path from one another. So antiderivative is not as easy as the derivative, because based on your function, you have many different ways of finding antiderivative. But for now, we have two things. One is antiderivative of polynomials or something related with x. I mean, easy polynomials or something like those. And trig, there are two things for now. Later, we are going to learn about substitution method. But for now, it's just two rules. One is you have to memorize these antiderivative or learn some tricks to remember them. And another is what is the antiderivative of a variable. So previously, we've seen that when you have a constant, not a coefficient, when you have a constant, its derivative was 0. So if you have a number here, you took the derivative, it became 0. Now, if you go backward, one step back, what gives you the number is the same number times same number times x. So antiderivative of a number is the number times variable. If you're working with x, it's x. If you're working with y, the variable is y. If you're working with t, the variable is t. If you're working with z, the variable is z. So whatever variable you're working with, the antiderivative of any number is the number times the variable you're working with. So if you take the derivative of this, it becomes the number. If you take the derivative of the number, it becomes 0. Similarly, previously we said if our function is x, its derivative was 1, right? Now you're going backward. What is the antiderivative of x? Now comes the rule. Antiderivative of any variable is the power plus 1, whatever sum you get from the addition, you divide by that. So it's the opposite of derivative. For derivative, first we brought the derivative down, and then we subtracted 1. Now you're going to the reverse direction. You add 1, and then you divide by that, not multiply. So if you connect with derivative, for derivative of x to the n, we said n comes down and then n plus 1. So first step was n, second step was n plus 1. Sorry, minus 1. Thank you. Going backward, it's the other way around. First, you add 1 with that, and then you divide by that. So derivative means multiply minus 1 from the power. Antiderivative means add 1 and then divide by that. That's it. This is the rule for antiderivative.
Oh, it's not right. That's
When you take the antiderivative, we have to add some extra constant, because when you take the derivative of this, derivative of this is 0, so we get the original function back. So usually when you find the antiderivative, you always have some unknown constant there. Sometimes we ignore that, sometimes we don't ignore that, but it's always there. Just like when you take the derivative, remember when you take the derivative, we have dx over dx, but did you ever write that? We did not, because it becomes 1. Same thing for constant. We sometimes we make it visible, sometimes it's invisible, but it's always there. Okay, so the rule for antiderivative is one rule for now. It's add 1 with the sum, you divide by that. That's what you have to remember here, and then you have to remember your trig rules. So let me show you a few of them. So previously we said derivative of the sine is what? Cosine. I should write in the middle. Derivative of the sine was cosine. And we said derivative of the cosine was negative sine. I'm ignoring my angle. Okay? Now, if you go backward, antiderivative of cosine is sine. Antiderivative of sine will give you negative cosine. Okay. So derivative of sine is cosine. So if you take the antiderivative of cosine, it becomes the sine function. So let me write it here actually. Antiderivative of cosine is same as the sine function. And then we said before that derivative of cosine was negative sine. So if you take the antiderivative of both sides, this becomes cosine, but you're not looking for negative. So you divide by negative or multiply by negative, you get antiderivative of sine is negative cosine with your angle. Antiderivative of cosine is sine, but antiderivative of sine is negative cosine. Why? Because we derive them from the derivative. So if you know your derivative well, you don't have to memorize the antiderivative, just derive them like me. If you know how to move forward, then you can go backward using your forward move. If you don't know how to walk backward, memorize. So the antiderivative of sine is negative cosine, Antiderivative of cosine is sine. Antiderivative of secant square is tangent, because derivative of tangent is secant square. So when we do the antiderivative of secant square, it becomes a tangent. By the way, if you put antiderivative and derivative at the same time, they cancel out because they're reverse of one. So all these rules are basically the derivative. You are applying antiderivative to them. If you know your rules, that means you're ready for take the derivative, antiderivative. It says find the antiderivative of this function. So for antiderivative, we use this symbol. And then who can tell me the antiderivative of x squared? What do you do with the 2? You add 1 and then you divide by that. So it becomes x cubed over 3. Simple, right? What is the antiderivative of x cubed, Apollo? X to the 4 over 4. That's because with the 3, you add 1, and then the sum, you divide by that. And then we put some constant. We do that because when you take the derivative of this, it's supposed to get this back. So you can actually always check your antiderivative by taking its derivative. If you take the derivative of the antiderivative, it's supposed to get the original function back. So when you take the derivative, what's the derivative constant? 0. Do you have anything here? No, we have plus 0, the invisible 0. For beginning, yeah, no problem. Go ahead. So antiderivative is sin in the front, dx in the back. It means antiderivative of f of x with respect to x. But when you keep doing antiderivative, you forget about the dx. But since I'm teaching you, thank you for reminding me. The next one. How do you think we should proceed? See, for derivative, we have a quotient rule. For antiderivative, we do not have a quotient rule. It's x plus 8 plus x squared, whole thing divided by square root of x. What can we do so that we can use our antiderivative rule? Perfect. Split and rewrite. If you do that, then you get individual x. So here we have 8 times x to the negative 1/2. X to the what we get in the second term? Any idea what do you get from the second term? Ellen? Square root of x, which is x to the 1/2. Actually, let me show you the work. I don't want you to feel confused. So we have 8 over x to the 1/2. Here we have x to the 1 over x to the 1/2. Here we have x squared over x to the 1/2. In division, we subtract the power. So in other words, from here, you get x to the 1 minus 1/2. That gives us 1/2. From here, you get x to the 2 minus 1/2. What is 2 minus 1/2? 3/2. And here, we bring the denominator onto numerator, so the power becomes negative. So in other words, we have our f of x as 8x to the negative 1/2 plus x to the positive 1/2 plus x to the 3/2. This function is same as the function they gave us on the top. That means now we can find the derivative. Sorry, antiderivative. So we put the antiderivative symbol, f of x, and then we indicate that we're taking the antiderivative with respect to x. We have x to the negative 1/2. For now, put it there. I don't want it to start with something bad habit. It's my bad habit. So how do you find the antiderivative of this? We add 1, right? And what is negative 1/2 plus 1? 1/2. That means we divide by 1/2. Or you multiply by the reciprocal. So let me actually do it in the next step. 8 times 2/1 x to the 1/2. Next one, we have x to the 1/2. So you subtract 1. What is 1/2 minus 1? Plus 1, sorry, my bad, plus 1. What is 1/2 plus 1? 3/2. So you divide by 3/2, or you multiply by 2/3. X to the 3/2. And lastly, we have x to the 3/2. So when you add 1, what is 3/2 plus 1? 5/2. So you divide by 5/2. In other words, you multiply by 2/5 x to the 5/2. And then you have some type of constant we don't know. So 16 square root of x plus 2/3 x to the 3/2 plus 2/5 x to the 5/2 and the constant. That's our antiderivative. And you can always check your work by taking the derivative of this. I'm just too lazy to take the derivative. But usually, it's always a good idea to take the derivative and see if you get the same original function back. If you get the same original function back, that means you are correct. If you don't get it, that means something is wrong. So go back and check. Any question, comments? So Monday, we are not going to have an in-person class. I posted a video on Brightspace. Watch that. It's not antiderivative. It is antiderivative, but it's area under the curve. So it's chapter 4. I'm going to give you a heads up with chapter 4 with that video. Once we come back, I have a few of the questions left for antiderivative, few fun questions left. We are going to do this fun question in our next class, next Wednesday, plus whatever you don't understand from the video. Okay? Any question, comment, concern, anything before you leave? Nick, your exam. Goodbye, everyone. Have a good weekend. Be safe. Andy, OMG, I didn't see you ask me question. What if there is more than one solution for the first derivative? Usually when you have two solutions, one of them is acceptable, one is not acceptable. So most likely one of them will be not acceptable. So you see which one is not acceptable, disregard that. Okay. Any question before you leave, Andy? Any comments? Anything? Nick, wait.